Alrighty, folks. So here in 1.3 part 3, applying identities 1, you want to take a second and just check to make sure that you have those charts filled in. This would not be a case where you want to have wrong things in your notes. So with regard to completing these two charts, it helps you build that sequencing of the identities we talked about. So we started to notice how, still have my lightsaber. We started to notice how some of these values were repeating. So for instance, the sine of 30 was the same as the cosine of 60. And the sine of 45 was the same as the cosine of 45. Well, that's how we got to build our cofunctions table. When your angles added up to 90 degrees, your cofunctions had the exact same value. So that's that first little set of identities. You want to take a second and check your reciprocal identities there real quick. Okay, and there's your last two. The quotient identities are super similar to your reciprocal identities, except for the fact that we start to tie in that idea that sine is y. From your unit circle, cosine is your x coordinate. So that's how we develop these additional definitions. Remember your Pythagorean identities? You know, I kind of showed you this last week. This one is like the grand poobah identity. And then these other two are just sort of offshoots of the big guy. So this is the most important one. And then what's interesting, you know, just to point out, and again, just to aid in your memory, you know, we have 1 plus tan squared theta equals secant squared theta. And then the cofunction version of that is down here. So we swap out tan squared theta for cotangent squared theta, and we swap out secant squared theta for cosecant squared theta. So your cofunctions are tied together to make that third identity. Right, so again, our goal for today is to fill in what we know and solve for what we don't. So here in example 1, and again, I apologize for the poor image quality. I'm supposed to let theta be an acute angle. So what that means for today, if you're going to draw a picture to aid in your understanding, you want to draw your triangle so that it's in quadrant 1. Because if you think about acute, those are angles between 0 and 90. So it says theta is an acute angle, which means our answer is in quadrant 1. And what they want me to find here is, or what they're giving me rather, is this idea that the sine of theta is 0.6. Okay, here's the rub. We're starting to get off that unit circle a little bit. 0.6 is not a decimal you memorized. You memorize things like the square root of 3 over 2, square root of 2 over 2, 1, square root of 3 over 3, square root of 3. None of that is 0.6. Not one of those numbers that we run into is 0.6. Terminating, right? So what we're asked to do, just to be super clear, is to use these two beautiful pieces of information to find cosine. So what I'm going to do in step 1, and I always have you write the steps first. The very first step, and again, that first step is a doozy, is you want to make a choice. It's a multiple choice question, step 1, and you're writing your steps down. So if you could add this into your notes, please. Step 1 is to choose an identity, or choose a formula that ties together two things, that relates two things. So we choose an identity that relates your given, that's like the piece of information they give you in the problem, I highlighted it in blue there, that relates your given. So in this case, our given is just up there in the top right corner. It's that sine of theta is 0.6. Kind of blocked there a little bit with my tech. So we choose an identity that relates your given to your unknown. And in this case, my unknown is the cosine of theta. So, what am I trying to say here? In step 1, I need to find an identity that has in it one of the formulas that has the sine of theta, because that's what I know. And my unknown is the cosine of theta. That's what I don't know. So from your list of formulas that you took a nice chunk of time to get down into those notes today, I need you to choose. I'm going to ask for a little audience participation here. I need you to choose me a formula, kids. I need an identity that ties together sine and cosine. Royce. Tangent is one of them. So, I'm going to write, still in step 1, we know that tangent of theta is equal to sine over cosine. There's another one. Royce. Okay. Yeah. You're not wrong, though. There's another one. I like how some of you are looking at your quiz, looking at your charts and your notes. There's one more formula that relates what we know and what we don't. In other words, one more formula that relates sine and cosine. Go, Parker.
Sine squared theta plus cosine squared theta.
Yeah, is that what you're going to say, Royce?
Yes.
Nice job. So the question becomes, which one should we use, right? So this is the part that I have students sometimes struggle with, because you might pick a formula. So you listed these formulas, you got to decide which one actually is helpful. Fun fact, in algebra class, so this might be a throwback for you, you can't solve one equation that has two unknowns in it. The only way you can solve an equation in math class is one equation, one unknown, or two unknowns, two equations, that's a system, so on and so forth. So if you take a look, what we're going to do is we're going to fill in what we know, which is the sine is 0.6, and we're going to see which of these equations is the easiest to solve. So I'm going to go ahead, use my erasing tool. I know that the sine is 0.6. So I'm going to replace sine with 0.6. In this case, it's going to have to be 0.6 squared anywhere I see sine. So this sine of theta is going to turn into 0.6. And this sine of theta is going to turn into 0.6. And this sine of theta actually is going to turn into 0.6 squared, which is like 0.36, but we'll get to that in a second. And then you just got to ask yourself, well, like, which equation is the best one? Don't forget this was 0.6 squared. So what we'll see, if we follow that rule, one equation, one unknown, there's really only one of these options that's viable. One that would help me find cosine. So which one is it? Bree? Yeah, so this is the one. This guy here is the one I gotta use. Winner, winner, chicken dinner. I choose that one. So the question I'm getting is, why do we have to choose that one on the right? Well, so we're trying to find cosine. You get that? That is the goal of this problem. I gotta find cosine. Solving for a number for cosine. So if I try to solve this equation for cosine, just for fun, for giggles, because y'all asked, I'm here to serve, I would multiply both sides by cosine theta. So I have 0.6 equals cosine theta times tan theta Maybe divide both sides by tan just for giggles. I don't get a number. I get 0.6 over tangent theta. That doesn't tell me the value, right? This is the step students struggle with the most because you all don't like to be wrong. Fun fact, no human does, right? So what's gonna happen for my less tenacious students is that they're gonna pick a formula, it might be the wrong one, and then they give up. So what I'm gonna challenge you to do is, you know, if you get it wrong the first time around, I mean, you even have an erasing tool. You don't even have to flip your pencil over like we did back in the day to like actually erase. You just gotta tap on your erasing tool, pick another formula, try again. That's step one is the hardest because you might pick the wrong formula to start. But the more practice you get, the faster that goes, the easier that step is. Okay, step one's the hardest, kids. Does anybody have any questions about how we did step one? So we just laid them all out there. And this one, so Bree said this one works well. This is the one we're gonna work with because it does allow me the luxury of solving now for cosine squared theta. I can get that cosine squared theta by itself. So let's do it. So again, and now it's just a matter of using my crazy good algebra skills. I would take 0.6 squared. 6 times 6 is 36. Shove that decimal over a couple times. 0.6 squared. Oops, wrong tool. Sorry. 0.6 squared is 0.36. And then I'll bring down my cosine. Cosine squared for that matter. Equals 1. And then again, my goal is to, you know, solve this for cosine squared theta. I got to get this by itself, like it's a variable. So this is step 2. I'll walk you through all that. And then we're going to go ahead and subtract 0.36 from both sides. So we have cosine squared theta equals 1 minus 0.36. That is 0.64. Do you remember how to get rid of a squared? Yeah. You do. Okay, remember when you square root both sides though? This is a throwback. You need that plus or minus. And then the square root of 0.64.
8.
Yeah, it's just 0.8. Yeah, I got you. Because the square root of 64 is 8. And then we had a decimal. So yeah, 0.8. All right. Fun fact. This is the last step. You got to watch your plus or minus. So this is step 3. Let's go back to the beginning of the problem. Remember that our angle had to be acute. Your cosine value had to be in quadrant 1. We're trying to decide between positive and negative. And I'm saying you can only keep one of those. So in quadrant 1, is cosine positive or negative? Remember, cosine is x. So in quadrant 1, is x positive or negative? What do you think, Vera? It is positive, yeah. So we're just going to get rid of that last part. The only answer for this problem, the only possible option for cosine, is that it's positive 0.8. So you used an identity to find a trig function value. That is the goal of our lesson today. So the answer to part A is 0.8. All right, let's do it again. This time around, it's actually a little easier because we actually did a lot of work in part A ahead of time. Okay, before we jump into part B, I wanted to summarize the steps. I only had you write step 1. Step 1 is to choose an identity that relates what you're given to what you don't know. Step 2, you fill in what you know and you solve for what you don't in the resulting equation. Step 3, just watch your plus or minus, watch your signs. Now we know two things, because we did all that work in part A. So anytime there's an A and a B, you can always recycle what you know from part A to help you with part B. What I'm trying to say is we now have two given pieces of information. So if I'm starting with listing out my givens, in the original part of the problem, they told me that sine of theta is 0.6, and we just did some work to show that the cosine of theta is 0.8. So now I have to choose an identity that relates two givens to one unknown. So what identity do we have that relates tangent, sine, and cosine? Go ahead, Bree.
Tangent theta equals sine theta over sine.
Yes. It's the one we picked from before. So it all was not lost. We reviewed our quotient identity. So tangent of theta is equal to the sine of theta over the cosine of theta. So the first step is just to pick a formula. Does everybody see why Bree picked that one? Because it had sine and cosine and tangent in it. And then, well, hey, we know that the sine of theta, we know what that is. So I'm going to fill in what I know and solve for what I don't. So the sine of theta is 0.6. And the cosine of theta, that's just right here, that's 0.8. So our cosine is 0.8. 0.6 over 0.8, that's like 6 over 8. 6 over 8, 3/4. Is that what you're going to say, Royce? Yeah, nice job, man. So the tangent of theta in this problem is 3 out of 4. 3/4. Questions about that? Oh, you're doing it, kids. All right, let's try one more. Just reading the problem here. So here in example 2, it says, let theta be an acute angle such that this time around tangent is 3, or 3 over 1. Find the values of each of the following by using specifically trig identities. That's the rub, right? So we can't use the unit circle or anything like that. Specifically, we need to use the formulas that we jotted down at the beginning of this set of notes. So if you think back to example 1, the first step is to relate or find an identity that relates what we know and what we don't. So we know that the tangent in this problem is equal to 3. Can anybody give me an identity or a formula that relates tangent and cotangent? Feel free to flip through. Yeah, good job, guys. Go ahead, Parker.
Tangent of theta equals 1 over tangent.
That is a good one.
Without the other one.
I'd probably use the other one. Yeah, I would use the idea that the cotangent of theta is equal to 1 over the tangent of theta. And why I'm doing that is because I'm trying to find cotangent theta. I'm trying to solve for it. So picking the formula that has that already by itself on one side of the equal sign it's just less steps. Both would work, to be very, very clear, but this one is just a little bit easier. People, we know what the tangent of theta is. We do. Tangent of theta, using our powers of substitution, is going to get replaced with what we know about it. We know that the tangent of theta is 3. See that right there? Tangent theta is 3. So I can replace with that red box with 3 because those things were given to us. That the tangent of theta is 3. That's it. That's your answer. It's 1/3. So that's the thing with regard to the identity. Some problems are longer, like we saw in example 1 yesterday where you had to use the Pythagorean identities, and you saw that on your worksheet. Some problems are really short. So you just give me the identity and plug in your value. So you gotta like ride that wave, right? It's like life. Don't get too excited about the great stuff. Don't get too worked up about the bad stuff. Just keep it even. Yeah, what's up, Parker?
Does the acute angle have anything to do with
It does. So in yesterday's lesson, we talked about how this means our answer must be in quadrant 1. And I was going to get to that in the next part. So it's a nice segue. Yeah, we can't ignore that piece of directions. I was even saying yesterday, that's actually not easy for me to type. Like to type theta in there, I had to go into equation editor. So yeah, you're absolutely right. It's not something we should ignore. What's going to happen is it oftentimes just affects the sign, like the plus or minus, the polarity of our answer. So that's a nice segue into part B. So again, what we want to do is we now know 2 things. So once you work out the first part, let me be clear, you're allowed to use, we now know 2 things. We also know now that cotangent is a third. So we could technically think about, when we think about secant, we're trying to find a formula that either relates secant and cotangent or secant and tangent. Any takers on that one? Go ahead, Royce.
1 plus tangent squared theta equals secant squared.
Amazing, yes. So 1 plus tangent squared theta equals secant squared theta. Is that what you were going to say, Bree?
No.
Oh. Everybody okay with that choice? Cool beans. Okay, so now I just fill in what I know, solve for what I don't. So we're moving into step 2. So I have 1 plus, and we said that the tangent is 3. So I'm going to go ahead and fill that in. Tangent squared, don't forget to square it. So what we figured out there is that that is 3. And then that's equal to secant squared theta. So if I do 3 squared, that's 9. And then I would simplify that left side. The sum of 1 and 9 is 10. And remember, I had to find secant in this problem. That's what I'm trying to figure out, not secant squared. So I do need to square root both sides. And if you remember from your algebra class, maybe even some of you this morning were doing this. The secant of theta has to have a plus or minus when you square root both sides. But then this goes back to Parker's question from earlier. Does that disclaimer at the beginning affect our answer? So when you square root both sides, we always know that there's basically going to be 2 solutions to that problem. But because we're in quadrant 1, bless you, because we're in quadrant 1, secant and cosine are positive in quadrant 1. So really only one of these answers holds some water. The answer to this one is just the positive square root of 10. Now, if we tweak that little given piece of information at the beginning to say, hey, you know, theta's in quadrant 2. Well, in quadrant 2, cosine's negative because x coordinates are negative, so I'd have to keep the negative answer. So, yes, Parker, you were very smart to pay attention to that detail. It does come in a little later. All right, that rounds out your 1.3 part 3 notes.